Hello everyone, my name is Imran Iftikhar, and this video is going to go over bit string flicking, which is a topic on the second contest of ACSL. This is one that's pretty simple once you get the hang of it. It's very straightforward, and the topics that we discuss for bit string flicking are used in other topics in later contests, such as Boolean algebra and digital electronics. So the first thing we need to figure out when we do bit string flicking is what exactly is a bit string. And so a bit string is, as the name kind of implies, a string of bits. And if you recall from contest 1, a bit is a value that is either 1 or 0. It's a binary value. It's a binary digit, so it's a bit. And so a bit string is just a string of many of these bits put together. So for example, 1010011001 is an example of a bit string. So in ACSL, the bit strings we'll encounter are 5 bits long. So it's a string with 5 characters, each of which is a bit. As we can see here, it's either 1 or 0. So the object of the ACSL questions is to modify and perform operations on these bit strings in order to come to some answer. And so the operations we can do on a bit string are not, shift, circ, and XOR and OR. And I've oriented them in this way because there is an order of operations for these operations. The order of precedence is as it's listed here. The highest precedence is not, followed by shift, then circ, then and, then XOR, and then OR. And the helpful acronym to remember this is take the first letter of all of these words, and you get NSCAXO. So the acronym for the order of operations. It's not PEMDAS, because we're not doing numbers here. It's NSCAXO. Although it is important to remember that there will be parentheses, and always, always, always nested parentheses are first, as you may be accustomed to. So now let's go over exactly what these operations do. So the NOT operation is performed on one bit string. It takes one bit string as an argument, and it's a bitwise operator. So effectively what it does is it takes each bit and flips it to the other option. So it flips ones into zeros and zeros into ones, and we can see that in this example here. So for this first bit, 1 becomes a 0, this 0 becomes a 1, this 1 becomes a 0, this 0 becomes a 1, and this 0 becomes a 1. So bit by bit, you just flip the values. That's what NOT does. Next in the order of precedence is shift. Shift is done, like NOT, on one string, but it also has other arguments. The other arguments here are R or L, and then a number that tells us how much we have to shift. So let's do this example. R shift 2 on this string, 1, 0, 1, 0, 0. All right, cool. So what we're going to do first is, as the name implies, we're going to shift this whole string 2 places to the right. So right shift indicates the direction, and 2 indicates how much we're going to do it. So now we're left with blank blank 1, 0, 1, and then these 2 zeros just kind of hanging out in the middle of nowhere. So for shifts for these zeros, we're going to just cancel them. They're deleted, they're gone forever into the abyss. And these 2 empty spaces, what we're going to do is we're going to fill them with zeros. And so our answer is ultimately 0, 0, 1, 0, 1. We shifted the whole bit string to the right 2, and filled in the blanks with zeros. If you had a left shift, you would shift everything to the left, and then again fill in the blanks with zeros, and you would shift it the appropriate amount of times. This can be 1, this can be 4, this can be 5, this can be 8. If you shift something over 8 times, then of course the whole result will just be zeros, but that's what shift does. All right, let's move on to circ now, which is the next in the order of precedence. So circ is done on one string, and like shift has the same arguments, R or L, and then also the number of times we're going to do it. So for this example, we're going to take this string, 1, 0, 1, 0, 0, and we're going to L circ it 3 times. So we're going to circulate it to the left 3 times. So circ, as you may kind of get from the name, we're going to shift it over to the left once just to show you how it's done. But then instead of deleting that 1, what we're going to do is circulate it and bring it back around to the now empty spot. and we're just going to do that 3 times. So the first time we do it, we're going to shift it over 1 and bring that 1 over here. Then we're going to shift it over once more, but instead of deleting the 0 and just strictly shifting it, we're going to circulate the 0 back here. And so then we're going to have 1, 0, 0, 1, 0. And then because we have to do it 3 times, we're just going to do this one more time. And we're left with 0, 0, 1, 0, 1. So for shifts, you're going to move over the bit string and delete the hanging entries. But for circulations, you're going to shift the bit string and just populate the blank digits or characters with the hanging digits. You're effectively circulating around the bit string. And again, this can be done towards the right and can also be done with a different number of digits. All right, cool. So the next one in the order of precedence is AND. AND takes 2 strings as arguments, and like not is bitwise. So the rule for AND is if you're comparing 2 digits in the bit string and they're both 1, then the result will be a 1. Every other case, it's just a 0. 1 and 0 is a 0, 0 and 0 is 0, and that's all there is to it. So here we can look through this. We're going to compare each digit of the bit string. So we're going to take 0, 0, 1, 1, 1 and 0, 1, 1, 1, 0. And we're just going to go through each digit as they appear and compare. 0 and 0 is 0. 0 and 1 is 0. 1 and 1, as we said, 1 and 1 is 1, so this will be 1 right here. 1 and 1 is 1, and 1 and 0 is 0. So the result answer from this AND expression is 0, 0, 1, 1, 0. The next on the order of precedence is XOR, which takes 2 strings and is bitwise. And so for this one, the result will be a 1 if you have a pair of 1 and 0. 1 and 1 is 0, 0 and 0 is 0. They have to be different. It has to be a 1 and a 0. The order in which they occur, whether or not the 1 is on the top or the bottom, doesn't matter. It has to be a 1 and a 0. So here if we go through this, 0 and 0 is 0. 0 and 1, well, that's a pair of 1 and 0, so that's 1. 1 and 1, 0. 1 and 1, 0, and then 1 and 0, well, that's a pair of 0 and 1, so the answer is 1. Finally, there's OR, which, again, 2 strings and it's bitwise, and the rule for OR is if there's a 1, it's a 1. So 0 and 0, 0, 0 and 1, well, there's a 1, so it's 1. 1 and 1, there's a 1 there, so the answer is 1. 0, 0 is 0, 0, or 1 and 0 is 1, because there's a 1 up here. So again, for all of these bitwise operations, that compare 2 bit strings together, so that'd be AND, XOR, and OR. What we're going to do is effectively line them up one on top of another and look at each character place, each digit. We're going to look at this column, then this column, this column, this column. You do it by character, by bit. That's why it's called bitwise. Cool. So now we're just going to run through some problems really quick. ACSL tests 2 distinct question types, which are simplifying and solving expressions, and then solving equations for an unknown x. The first type is pretty easy because you can just kind of do it. You can just solve it out. It's very much like arithmetic. You don't need to think that much. There will be some cases where they'll say like solve for x, and then it'll just be x equals, and then a big expression. Effectively, that's just asking you to simplify the expression, right? So you don't need to do any sort of thinking for this first one, other than the rules we just went over. So let's go over one right now. So here we have simplify the following expression. RCirc 2, 0, 1, 1, 0, 1, or L shift 1, 0, 1, 0, 1, 1, and not LCirc 3, R shift 2, 0, 1, 1, 1, 0. Now, I told you earlier there's an order of operations. Keep that in mind, and SCACSO, I recommend you commit that to memory for the exam. But there's nested parentheses here, so we have to go with the most nested first. And in that case, it is this R shift 2, 0, 1, 1, 1, 0. And this is what we have. We're going to effectively shift the whole thing over to this 1 and 0 are cut off, so we're just going to nix those. They're gone. And we're going to replace this empty space with the 2 zeros here. So this R shift 2 now becomes 0, 0, 0, 1, 1. And then we're going to LCirc that. So we're going to shift this to the left, or circulate this to the left 3. So imagine it moves over 3 places. And then these 3 are just going to circulate back over to the right side. So we're left with 1, 1, 0, 0. 1, 1, 0, 0, 0. And now we're going to knot this, which should be pretty elementary to do in your head. You just flip all of these, so this becomes 0, 0, 1, 1, 1. And we notice the next thing we have to do here is AND, but there's nothing to AND with because we need to solve this expression first. So we notice an R circ, an L shift, and an OR. For the order of precedence, we're going to do the circs and shifts first before we do the OR. Remember in SCAXO. So here for this R circ, we're going to bring these two and circle them back around to the left. So it'll be 0, 1, 0, 1, 1. And for this L shift 1, we're going to shift everything over to the left, and we'll end up with 1, 0, 1, 1, 0. So we'll end up with those values. When we OR these, again, we'll go bit by bit. So for this first bit, there's a 1, so it's a 1. For the second bit, there's a 1, so it's a 1. For this third bit, there's a 1 present, so it's a 1. For the fourth bit, there's 2 1s present, which is at least 1 present, which is 1. And this final bit, there's a 1 and a 0, which will end up becoming 1. So we're left with 1, 1, 1, 1, 1, and 0, 0, 1, 1, 1. Recall from our AND rules that there needs to be 2 1s present for there to be a 1 in the answer. 1 and 0 is 0, 1 and 0 is 0, and then these last 3 are all 1 and 1. So the answer is 0, 0, 1, 1, 1. As you can see, that was pretty easy. You kind of just need to do it and remember the rules and remember the circs and the shifts, and just do the 1s and 0s. This is the next type of question they'll test you on, which is a bit harder because now they're asking how many values of x satisfy the following equation. And now instead of just simplifying, you kind of need to think about, wait a minute, I need to figure out values of x that are bit strings that make this true. And so the best way to go about these is to say, let x be a 5-bit long bit string such that x is represented by A, B, C, D, E. And all of these A, B, C, D, and E are bits. They're either going to be 1 or 0. And that makes sense when we think about it because then x is definitely a bit string and we can solve this. So I've rewritten this expression here and just replaced x with A, B, C, D, E. And all of the letters here are bits. We just don't know what they are, so they're represented by variables. And so what we're going to do now is solve this with the letters. And let me show you how that works. So as usual, the first thing we're going to do is the innermost nested parenthesis, which is this one. And within this parenthesis, there's an OR and an AND. And as we remember from in SCAXO, AND comes first. So we're going to do this expression right here, 0, 0, 1, 0, 1, and A, B, C, D, E. 0 and A, remember, for an AND, there have to be 2 1s present. If there's a 0, it's automatically 0 in an AND. So we know that this first bit's going to be 0. The second bit, 0 and B, is going to be 0. Now 1 and C, what ends up happening is if C is 1, then it's 1. And if C is 0, then it's 0, right? So we can just say that the value of this third bit is actually just C. Whatever C is what the value of this third bit would be. D and 0 is going to be 0, and then E and 1, like C, we can state that the value of this bit is going to be just whatever E is. So what we're left with is 0, 0, C, 0, E. We plug that back in, and now all we have to do is just the OR with this 0, 1, 0, 1, 0. And what we're left with is 0, 1, C, 1, E. And the reason this happens is because 1 and 0, or 0 and 0 is just, or 0 or 0 just makes a 0. 1 or 0, well obviously that makes a 1 because there's at least one 1 present. 0 or C, now let's think about this here. If C is 1, then it's 1. And if C is 0, then it's 0. So again, with the OR here, we know that whatever this value is just C. So 0 or C is just C. 1 or 0 is 1. And then 0 or E, same thing with C, you're left with whatever the value of E is here. So next we're going to R circ this. We plug it back in and R circuit. So what we have here, when we do this R circulation, we're going to circulate this all to the right. So we're going to take these 3 elements that are the rightmost and just circulate them all the way back to the leftmost side of the equation. So we're left with C1E01 equals 11001. For this expression to be true right here, C has to equal 1 and E has to equal 0 for this to be true. But recall at the start, we had A, B, and D. And what we'll notice is that A, B, and D aren't included here. Like, they don't have to have any particular value. They can be anything. They can be whatever they want, right? So A can be 1 or 0, B can be 1 or 0, and D can be 1 or 0. And so they each have 2 possible values, and the question was asking how many unique values of x are there. This means that there are 8 unique x values that satisfy this expression. I hope this made sense. If you have any questions, reach out to a senior member of the team or a teacher. Remember to consult the ACSL wiki if you have any questions, and also to go through the practice problems that you will have access to. Good luck with ACSL2 bitstring flicking, and thank you for your time.